Hi friends, welcome to Follow Up. Let's have a look at today's daily challenge problem. Problem 852. Pick index in a multi-array. So a multi-array is an array which satisfies the following properties. So first, the length is at least 3. And secondly, so one part of the array before index I is strictly increasing, and afterwards it strictly decreasing. So here, given a multi-array, we want to find the index I, which we can see it's a turning point. So we must solve this problem in O logarithm n time, where n is the length of the array. So this hint actually is very suggestive. Basically, it leads us to think about binary search. So here are 3 examples. So the first 2 examples, the return is 1 and 1, and in the third one, it's also 1. So here, after this index, then the array begins to decreasing. So the constraints are the following. First, the length is this bounded above by 10 to the power 5, and the 10 to the power 5 is a decent large number, right? And the element is in between 0 and 10 to the power 6, and the array is guaranteed to be a mountain array. So here our strategy is to do binary search. So actually the key point for this problem is to digest how to do search range shrinkage. So actually if you have practiced quite a lot problems on binary search, you can compare this problem with leetcode 33, search in rotate sorted array, or you can check out our playlist, which contains 30 or more questions which can be solved using binary search. So here, to digest, we are going to present 3 methods or solutions. The first one is a brute force one, let's see. So basically we can find the maximum and then we get the index, right? So basically we can write this in one line, but for clarity let's do something like this. So first we call this max function, we get the largest element, and then we just need to return array index, this capital M, right? So we search its index location. So this way of brute force basically is a linear time solution, which does not satisfy the requirement here. But now let's first do a test. Yeah, it passes all the cases as it should be, right? So now let's quickly share with you another method, which basically another linear solution. Basically, we just need to check the index where the index is larger, is smaller than the previous one. Then we just need to return the previous index. For example, here, so at this index, 5 is less than 10, so it's the index 2. We just need to return index 1. So this is very simple. So let's see, n is the length of this array, and then basically for I in range, so we start from 1 and ending at n minus 1, right? So if array I is less than array I minus 1, so due to the way we write the range, so I minus 1 is always inbound. So thus we found this one, array I is smaller than the previous one, so we just need to return I minus 1. So that's actually it. So let's do a test again. So here this is V1 we have changed, so this should also test this one. Yeah, it passes all the cases, but these are not linear logarithm time solutions. So now let's look at the binary search solution. So actually for this problem, the binary search solution is very easy to digest. So let me first write down the code, and then we explain and explain why it suits the general thought process for binary search. So first here, let's get this m, right? Array. And then we are going to set a low and a high, so be 0 and n minus 1. So this is the left index or right index. And then we want So typically in binary search, we should have a Boolean function to produce order, and also we need to have a search range shrinkage. So here, let me first write down the code and then explain it. So while low less than high, right? And then we have made equals. So here low plus. So I'm writing like this: low over 2, right? Because this high minus low is the search range. I shrink half. So here I'm starting from low and add this half. So here now let's look at the Boolean function. So basically what we want to check is array made. So we want to check if this one is less than array made plus 1. So in this case, we know that we are still in the first increasing half, right? So we are going to set low to be made plus 1. So the rationale is that so the targeted index can only be made plus 1 or larger, right? So other case, so we're going to set high to be made. The other case is that the array at mid index is greater than or equal to mid plus 1. It means that the turning point is to the left of the mid. So notice that due to the way we write this, so array at low is always possible to be the turning point. So we are going to return low for this case. Let's first do a test. It passes all the cases. So now let's explain why this solution suits the general method. So here, that's the main point. So here is the search range shrinkage is basically the key for this problem. Actually, for this problem, I feel that it's easier than this one in determining the search range. You can make a comparison. So typically in binary search, right? So we do two things in general, right? So not just vanilla determining if an element is inside an array, sorted array or not. First is Boolean function to determine order, right? So it's also hints on the shrinkage, the search range shrinkage. Second is search range and shrinkage. So here, actually, this is a Boolean function, right? For each index. So basically, we check if. So you can write the Boolean function like this. Define check. Given the index, what we want to check. If the array I is less than or less than array mid plus 1, right? So here you just need to check, right? If this is the case, if check mid, so we are going to do this. Otherwise, so we are going to set like this. So now let's test this case. So this is the same, right? But we just need to put it in the general binary search thought process or paradigm. So with that said, I guess basically that's about it for this. Obviously, this is a very straightforward problem. So as we mentioned at the very beginning, so for this problem, the main thing is to check to do search range shrinkage. So if you are interested, you are welcome to compare with this problem or check out our playlist for binary search. So with that said, I guess that's about it for this specific problem and video.